Hi everybody. Today we are going to see one of the application of stack data structure, that is how we are going to convert the given infix expression into the postfix expression. So any mathematical expression we can express in three different formats, that is infix, prefix and postfix. So if we are taking an example of infix expression, so that is A plus B. So infix expression means there are two operands, in between we are having the operator. So coming to the prefix, first operator will come followed by operands will come. So that is plus AB. And the third notation of mathematics is postfix expression. So where you can have operands A, B followed by the operator. So these three are different formats for mathematical expression, that is prefix, infix, postfix. And we can use stack data structure to convert the given infix expression into postfix. We can also use stack data structure to convert the infix expression into prefix. Today in our class we are going to see how exactly the given infix will be converted into the postfix by using infix to postfix conversion. First we will discuss the algorithm procedure, how exactly we will do the infix to postfix. So here first we will take the given infix expression and we are going to add left parenthesis to the stack and right parenthesis to the given postfix expression. So this is the first step. We will take some examples later on. First we will see what are the steps here. Then we are scanning the infixed expression from left to right and we are repeating this process. So whenever we get the operand, then we are directly send that operand to the postfix expression. That is case 1. And the case 2 is if we get any left parenthesis, simply we can push that left parenthesis into the stack. Third case is if you get any operator, so that operator we need to store into the stack. So whenever you want to push the current operator into the stack, we need to check these two conditions. So if already the operator which is present on the top of the stack is low precedence than the current operator, then we can easily push that operator into the stack. So for suppose if we are having the operator which is having the equivalent precedence operator or already high priority operator is there in the stack, then what we need to do, we need to pop out those operators from the stack, then we need to insert the new operator into the stack. So this is the steps we need to follow. So whenever we will get the right parenthesis in the expression, we need to pop out all the operators until open bracket encounter in the stack. So this is the procedure we are going to follow for infix to postfix expression conversion. First we will see some examples. For suppose I have some expression like some A plus B into C by D. So this is given postfix expression. So as per the algorithm, first we will add the open bracket to the stack. That is left parenthesis we are pushing into the stack. Then we are going to add the close bracket to the infixed expression. Now we are going to evaluate this infix expression from left to right, one by one, and we are going to execute that infix to postfix algorithm. So first I am encountering one operand. So whenever I am getting operand, simply I can add to postfix conversion. The next one is I encountered plus. So on top of bracket any operator I can push. There is no problem. So I am pushing onto the stack. Then I am encountering operand B. So that operand simply I can add for the postfix expression. Now I am encountered with multiplication. So what is the precedence of multiplication? It is higher than to the plus. So I can able to place that operator onto the stack. Yes, you can push that one. Next C. C is operand. Simply you can send to the postfix expression. You can add for the postfix expression. So now I am encountering division. So coming to the priority of multiplication and division, both are equivalent precedence operator. So we need to pop out this multiplication from the stack. So you can pop out and add to the postfix. Then you can insert division into the stack. Now what is the next? Next we are having operand D. So operand directly you can add for the postfix. So finally you are encountering with right parenthesis or close parenthesis. So whenever you are identifying the right parenthesis or close parenthesis, we need to pop out all the operators until open parenthesis. So what are the operators I am having in the stack? Slash, pop out slash, then you can pop out plus and remove that open bracket from the stack. So expression completed. Infix expression is completed and there is no operators present in the stack. It is also empty. And finally, this is the postfix expression for this given infix expression. So this is how we can use this stack for storing all the operators in the stack and how exactly we are going to convert into the postfix. So I will take one more example and explain you. So this is the expression I am having. A plus bracket B into C minus bracket D by E power F close bracket into G close bracket into H close bracket. So these are the steps. It is already present in the table. So I am going to explain you. As per the algorithm, what we need to do, we take a stack and insert left parenthesis or open bracket into the stack. Right? Now you can add this close bracket to the expression. The first step is completed as per the algorithm. Now we are going to evaluate this infix expression from left to right, correct by corrected. So first you are encountering with A. So what is A? A is operand. So simply you can add that operand to your postfix expression. So that is A. What is the next symbol I am having? Plus. So plus is operator and I want to store into the stack and I need to check what is the existing data I am having in the stack. So on top of bracket I can able to place any operator. So you can push plus to the stack. Now you got open bracket. Push open bracket into the stack. Then you are having next operator operand that is B. So you can send that operand to B. That operand B to the postfix expression. The next symbol you are having is star. That is multiplication operator. So I can able to push that multiplication operator on top of bracket. So you can keep into the stack. Now you are getting the operand C. So read that C and you can directly add that operand to your postfix expression. Now you are getting the symbol minus. So on top of multiplication I want to push minus. So it is high priority operator. On high priority operator, I cannot place low priority operator. Then what we need to do? We need to pop out the existing operator from the stack. So now you can pop out this multiplication to the postfix expression, and you can add that operator minus here. That operator minus here. Fine. Next, I am getting open bracket. The next symbol is D. So it is operand. Directly you can add for the postfix expression. Then you are getting next symbol, that is slash. On top of bracket, on top of parenthesis, I can able to place that slash. Next I can encounter the next character, that is E operand. So simply you can add for the postfix. Next here I having the symbol power operator. So on top of division, I can push power operator because the precedence of power operator is greater than to the division. So I can able to place on top of division that power operator I can able to place. Next, I am encountering the operand F, which I can add for postfix. Now I am getting close bracket here. So whenever you are getting the right parenthesis or closed bracket, we need to pop out all the operators which are present in the stack until open bracket. So what are the operators I am having? Power. So add to the postfix. Next you can pop out slash and remove this open bracket. So these three will be removed from the stack. The next operator is star. So existing top operator is minus. On top of minus, I can able to place star because the operator precedence for multiplication is greater than to the minus. So on top of low precedence operator minus, I can able to place star here. The next symbol is G, that is operand, which I need to add directly to the postfix. Now I am encountering with closed bracket. So as per the algorithm, whenever you are getting the closed bracket or right parenthesis, we need to pop out all the operators until one open bracket or one left parenthesis. So what are the symbols I am having? So pop out that multiplication, then you can pop out minus, then you can pop out open bracket. Fine. So what is the next symbol I am having here? Star. So on top of plus, I can able to place star. Now you can encounter the next symbol, that is H. H is operand, which I can add directly to the postfix. So finally, I am getting the close bracket or right parenthesis. So I need to pop out all the operators present in the stack until open bracket. So what are the symbols I am having? Multiplication, plus, and open bracket. Pop out that open bracket. So your infix expression is completed. And this is your required postfix expression. So check this. So this is how we can express step by step in the table also. So here I explain this with this symbol by using this picture to understand better way, but we can also implement by using step by step in the table. So this is how exactly the stack can be used for conversion of given infix expression into postfix. So it is one of the best application where we can use the stack data structure. So here I am going to explain you how we can write the code for this conversion of infix to postfix. So here I am defining the infix expression as a string because I am having operands, operators, everything in the stack, and I am taking the postfix and I am taking one stack which is character data type because I need to push all the symbols into the stack. So I required it is also a character data type. So initially, as per the stack definition, initially I am taking top is -1. So whenever the top is -1 indicate that there is no data into the stack. So first I am reading the infix expression from the keyboard. So by using the getTest function, I can able to read the infix expression. So as per the algorithm, what is the first step? We need to push open bracket into the stack. So I am writing that function push open bracket. Then I am adding the close bracket to the expression and I am evaluating all the characters in the infix expression from left to right. So this is the for loop. I am starting from 0 to null because infix of I is null means the infix expression is completed. So whenever I am encountering operands, that is from A to Z, those operands directly I am adding for the postfix expression here. The next case is if I encounter any symbol that is open bracket, simply I am going to push into the stack. For suppose if I am getting close bracket, until that open bracket, whatever the symbols I am having in the stack is going to pop and added for the postfix expression. Then finally I am removing the open bracket from the stack. Next, if you want to push new operator to the stack, we are checking the precedence. So precedence of existing top operator in the stack and precedence of the operator which you want to insert now. So if already existing operator precedence is low and current operator precedence is high, directly you can push. So on top of low precedence operator, I can able to push high priority operator. So there is no issue. So directly you can push that operator. Else, for suppose existing operator precedence is equal or greater, then what we need to do, we need to pop out that symbols from the stack and add those symbols to the postfix. Then you can push this new operator to the stack by using these steps. So finally, you can print out what is the postfix you are getting. The simple programming I am explaining here. So by using C programming, and you can implement this. So it is as per the algorithm of these steps. Okay. So this is the best application for the stack. How exactly the given infix expression will be converted into postfix expression. So to learn this concept, it is very important. Why we are learning this infix to postfix conversion is, this is how exactly the data will be handled in the memory. So to understand how exactly the mathematical expressions are evaluating in the memory, we require to know about these expressions. Thank you. Thank you one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.